the examples are actually the same. Okay? If you didn't print out your calculator, you're going to want it today. Okay? So I'm going to show you not only how to do this by hand, but also how to do it on the calculator. So you need to know both for the AP test. Okay? Alright. Alright, here we go. There we go. Okay. I got it now. Okay, here we go. Alright, let's do this. So, remember yesterday we talked that it is really good to make sure we know what the picture looks like. Okay? On the AP test, they may or may not give you the picture. On free response, they tend to give it to you, especially if it's not a calculator problem. Okay? Calculator problem probably won't have a picture. Graph it on your calculator. Okay? So, this is the one and only reason in math analysis I teach how to graph sine and cosine. So you have a general idea of what that looks like. Okay? Tangent and secant and those they don't come up as much. But sine and cosine, you pretty much guaranteed to see those graphs somewhere on the test. Okay? So, does sine start at 0 or does it start at 1? 0. Okay, so I'm really excited to remember that. You gotta do it basically does that thing, right? Yeah. Okay, so that's our sine graph. I'm gonna label that here. I'm gonna use a different color for cosine. Okay, where does cosine start? 1. 1, and it goes down first, right? Yeah. So cosine does something probably like that. And I can kind of start working it in. But all we're going to do is find the area of the region, and when they say that, they really want the first region, because it's obviously going to have more than one region. Okay? So all they're looking for is this area in here. Okay? So, what is the top curve? Which one? The red one or the blue one?
The red one.
The red one. So that the red one is which one? Sine or cosine?
Sine.
Sine. So sine x minus the bottom curve cosine x dx. That's how we find area, right? that the coordinates match, right?
Yeah.
So the first one, it's not zero, right? You can see that on the graph, they don't cross at zero. One's at zero, one's at one, right?
Right.
A little bit, it's a little bit moved in, so it's at pi over 4. I like it, good job. Okay, there is one other place on our unit circle where they're exactly the same. 3 pi. 3 pi over 4 would be.
Oh, so it was 5 pi over 4.
Yeah, it's gonna be this one here, right?
Yeah.
Three's over here. I'm right about that, right? It's right there. All right, so it's got to be this one here, but it's negative and negative, right? Okay, so that's the 5 pi over 4. Good. So we're gonna go from pi over 4 to. Okay, and if we're in trig, we would expect to see radian measures as our limits. Okay, because we don't really know how to find the sine of 1, right? So what we actually want radian measures. We know how to do those things, especially right now. All right, let's go ahead and integrate it. So when we integrate sine, what do we get?
Cosine.
There we go. We need a negative in front of it. Okay. All right, and it's minus when we integrate cosine. What do we get?
Sine.
Sine. All right, but the negative comes from the original problem, right?
Right.
Okay, and then we're gonna go from pi over 4 to 5 pi over 4. Which number do I plug in first? 5 pi over 4. So negative cosine of 5 pi over 4 minus sine 5 pi over 4 minus, and always in parentheses. There's a sign issue going on there. Okay, and then it's negative cosine of pi over 4 minus sine of pi over 4. Once you've got it set up, the biggest problem here is you have to work on the signs. Okay. All right, wrote out the unit circle, so what's the cosine of 5 pi over 4? Good. Minus what's the sine of 5 pi over 4? Good. And all the double negatives are going to go positive. All right. Minus of parentheses. It's a negative again. What's the cosine of 5 pi over 4? Sorry, pi over 4.
Square root of 2 over 2.
Square root of 2 over 2 minus square root of 2 over 2 again. But what do we need to do with that negative sign? Okay, and I'm going to be lazy about it, right? That's how Mrs. Bauer gets lazy and writing it again. So I'm going to switch them all to pluses. Good news is they're all plus signs, right? How many of these square root of 2 over 2 do we have? 4 square root of 2 over 2, which reduces to what? Square root of 2. Really was not that bad doing it by hand. Okay, because we can handle the fractions, the radicals, we're not scared of those things. Okay. Okay. My 4th grader, she's telling me she isn't scared about fractions, but she can do multiplication. They teach it a lot differently than you guys think. You guys are probably taught I had to figure it out. I took me 5 minutes to figure it out. And the division, don't even get me started. She does something like this. She does a 7. She does this. Like do something over here with it.
I didn't know what that is.
I know. So I'm like, okay, show me how to do it. And I let her. She was much better at the division.
You just get like working in
Okay. All right, the multiplication makes sense to me, and I think mine's easier than the division. Okay, let's keep going. Okay, so let's talk about this one. This is very similar to what we did yesterday. Okay, it's more of the same. Listen. All right. Again, we're going to pretend we don't have our calculators, and we've got to figure out what that looks like. Okay. What kind of a shape is this making? Parabola. Is it going to open up or is it going to open down? It may or may not factor. I think that I kind of want to say this one probably doesn't factor, so it's probably means something along these lines. Do I have to draw it perfectly? No, it's a sketch for you. Okay, so you can kind of get an idea of what's going to be, where the graphs will be located. Okay? All right. What's this a picture of? What's its y-intercept? Y. So it's going to be somewhere up here with a slope of 2. So we can at least see. Okay. Whatever. You know, one's on the top and one's on the bottom. I was trying to make it fit on my graph. My scale is off. Okay. All right. If I did like one right here, right? One right there. Right there. Whatever. Okay. So. Is it enough? Is my picture at least enough to understand what's on the top and what's on the bottom? That's the point of the picture, not that I graphed it perfectly. Alright, so what's your bottom
X
function?
squared plus 2x plus
Plus 1, good, and throw a dx after it.
1. Yeah.
Okay. I gotta figure out my limits. How am I gonna do that?
Set the equal to each other.
Set them equal to each other. Okay. And you'll notice that yesterday I think we had y equals there, and today they named them f and g. We actually would rather they named them f and g. Okay, than y. Alright, I'm not gonna show you y today, but I'll show you y probably next time. Alright? Alright, what am I gonna do to move the 2 over?
Subtract it.
Oh, subtract it. So when I move that 2 over, what happens with the 2x?
Cancel.
So should I bother moving the 5, or is it better to move the 1?
So move to the 1.
It's better to move the 1, so when I subtract the 1 over, I get good. So I get x equals
2.
just 2. Because I'm taking the square root, we want plus or minus. Because how many points of intersection was I supposed to have? 2. Okay. Negative 2 to 2. Good. Alright. Let's distribute our negative and do some canceling if we can. So I'm going to take this guy, put him in there. You know, Mrs. Bella's lazy, especially on Friday. So, I'm going to encourage your laziness. Okay. So, we've got, let's see. It looks like the x squared stays, right? I got 2x and negative 2x. What happens? They cancel. And then we got 5 minus 1 is 4. Throw a dx after it. Alright, we're going to integrate it. And again, the integration step is usually the easy part. Okay? It's the algebra pieces that are usually the more difficult where the mistakes are made. So negative x to the third over 3, good, plus
4x.
go from negative 2 to 2. Alright, what number is going to go in first?
2.
Positive 2. So 2 cubed is
Negative 8.
8 over, and the negative 8 comes from the negative from the problem. 4 times 2 is 8, minus, and we have to put parentheses, good. I've got a negative sign. Negative 2 cubed is 8.
8.
Negative 8 over 3, the double negative is going to go positive. 4 times negative 2 is negative 8. Alright, what do we want to do?
Distribute.
We want to distribute, so it's going to make this one negative and that one positive. And again, I'm going to use that little combining like terms trick before I try to make equivalent fractions of it. Okay? Alright, so what is negative 8 thirds and negative 8 thirds?
0. Oh, what? No.
There you go. Negative 16 over 3.
Sorry.
Yeah, I was looking at the double positive, right? I missed my little blue mark up there. Alright, it's okay. It happens. It's Friday. Alright, what's 8 plus 8? 16. And again, if this was free response, you could have actually stopped right here on this line or here. We don't have to keep going to this multiple choice. We don't have to. I got to make this 16 into thirds.
Yes. 48.
48, good. And so negative 16 and positive 48 is 32. Yes, the only benefit to you right now to keep going is you are going to be able to check your answers in the book, right? The answers in the book are going to be simplified on the way they stop. Okay, good.
Yeah. I have.
Even sometimes my teacher's efficiency doesn't stop. Alright, let's look at example 5. Alright, on this one here, it's a little bit tougher to tell what's on the top and the bottom, right? Okay. We're going to use our calculator to assist us with this one. We're still going to do the integration step by hand. On the next 2, we're going to talk about doing them on the calculator. Okay? So I need everybody to get it graphed. Okay, so everybody put it into your calculator. Alright, so we've got 3 x to the third minus x squared
Always waiting.
minus 10x. We're gonna hit it.
Wow.
Alright, that's the cubed one, and then once you're done with that one, let's put in the squared one. So negative x squared show you some tricks here, especially the next one.
Yeah, well,
Tips and tricks today. Alright, you want to make sure you can see where your intersection points are. Okay? Now,
right there.
yeah. How many intersection points?
Yeah.
3, right? There's one right here too. It's almost better to see the intersection points than the. Let's see if I can photograph this guy. Okay, 1, 2, 3. I am going to use the benefit of the calculator to save us some time. Let's calculate points of intersection on the calculator. Okay. We could all set it equal to each other and do that part, but we'll analyze graph intersection. Go to the left, go to the right, find the 3 points of intersection. And all we're caring about is the x values. I do not care about the y values.
Oh wow, down there.
Oh, not yet. You need to understand this by hand before I try to do that with you. Okay? That's next.
See what?
Shh. Don't let there. Alright, once you have that, go ahead and sketch this into your notes. Okay? Give you about a minute, get it sketched, because I want you to make sure you have it in your notes so you know what the graph looks like. If you have 2 different colors, it's not a bad idea to put it in 2 different colors right now. Okay?
Look.
I'm going to give you about another 30 seconds, then I'm going to start talking about it. Okay, so let's talk about finding the area of this thing if we're going to do it by hand. And again, this is one, they would have given you the picture. You would have had to find it. They may have even been nice enough to give you the points. Okay, at least on some of them. So what we learned yesterday and today is that we're supposed to do the top curve and the bottom curve. What's the problem with this picture? Just the same. At some point, they're both on the top and they're both on the bottom, right?
Correct.
So, we can split it up into 2 integrations. That's what we're going to do. Okay? So, let's see, if I go this first region, so my x values are 2, 2, 0, -2, 0. From -2 to 0. Okay? Which curve is on the top? The blue one or the red one? The blue one. So I'm going to write my blue one first, right?
Yeah.
So I'm going to do 3x cubed minus x squared minus 10x. We're going to subtract parentheses my red one.
Yeah.
So -x squared plus 2x dx. Then we would add that to the next region. So yeah, it's not a short problem, right? Okay, we'll do some combining like terms to make it a little better. All right, so my next region is from this x value of 0 to the x value of 2, so 0 to 2. Okay. What function is on the top? The red one or the blue one?
Red.
The red one. So we've got -x squared plus 2x minus parentheses my blue function. 3x cubed minus x squared minus 10x dx. Alright, because I really don't want to have to write this 6 million more times, right? What would we do with our negative signs here? Distribute. So I'm going to swap all my signs there. So we're going to make it plus, minus, plus, plus. Now I would probably do some algebra and combine like terms so I can eliminate some integrating here. Alright, so I've seen a 3x cubed. -x squared and +x squared, what's going to happen? Cancel. Alright, -10x and -2x's. Good, that's looking negative 3x cubed. Negative x squared and positive x squared is going to be cancel. Okay, and then 2x plus 10x is 12x dx. Okay. All right, let's go ahead and integrate it. Basically, the difference is there's some sign differences, right? So it's the same problem. All right, 3x to the fourth over 4 minus 12x.
Squared over
Let's think about that. 12x squared over 2. What's that really going to be?
6x.
Yeah, let's save ourselves a line of work. Okay. So 6x squared. Good. And that's got to go from negative 2 to 0. And then this one would be negative 3x to the fourth over. So same thing, right? This one would just be the positive version of this one. So 6x squared. And then that has to go from 0 to 2. Okay. When we're integrating, sometimes we ignore the 0. It's when the 0 is the bottom number. When it's the top number, it's very important that you don't ignore it. Because it's going to have you can make a sign mistake. So remember, it's always the top one minus the bottom one. So when I put 0 in here, what do I get? Not a bad idea to write it down as a placeholder and 0 minus parentheses. Because see what I just did? I introduced a negative sign, right? That's going to give me some sign issues if I don't take care of it. Okay? Alright, negative 2 to the fourth.
16.
16 times
48.
48.
12.
And it's going to be positive 48 over. Okay. We'll see if let me do the other one first, and then we'll see if we can reduce it. Okay. All right. What's negative 2 squared? 4 times 6 is 24. 24. Okay. Then we've got to go plus. We're going to put in a 2 to the fourth, and we get 16 times negative 3 is negative 48 over 4. And we'll reduce it a second if we need to. Okay. What's 2 squared? 4 times 6. Is this 0 going to matter? It's minus 0. You need to write it down so you know you take care of it. Great. If not, you don't have to. Okay. All right. What do we need to do with this sign right here? Distribute it in. Okay, so I'm going to distribute that sign, which is going to go negative, positive. All right, let's see what we can do with this. You guys have been dying to get these reduced, right? You know that that's negative 12 and negative 12. What's negative 12 plus negative 12?
That is 24.
Can't I go like this?
Whoa.
What's left?
Whoa.
I always look for where things can cancel, even if I have to add two things together and get them to cancel.
Well, that was great.
Okay. Go with this one. It's all additional. It's just like
That's
I
a
dropped
really
one.
satisfying answer.
I added negative 12 plus negative 12 and then negative 12.
That's a satisfying.
Are we good? Okay, are there an example 6 and 7?
No.
Okay, good. Because they're example 1 and 2 on the next one. I don't know why my 6 and 7 is still in this. Alright, let's flip to the next set of notes there. Okay? That's the next set. Go ahead and write that essential question down.
Am I right in there? I feel your pain.
Let's say 7-3. She's
was a fight. And she threw me
And
the
I slipped and I hit my head against one of the machines. It's really hard.
Alright, so let's get it checked out.
You can still do calculus, you're all right.
I don't know.
Okay.
I multiply 6 times 4.
Calculus always makes you feel better.
Yeah.
Okay. It makes me feel better. Alright, so here we go. We're gonna still kind of look at we're gonna look a little bit more at the same stuff. Okay, that's basically what we're doing. Alright, so we're gonna use the calculator to find the entire region. Okay? Okay, I'm gonna teach you our little trick today. So on the AP test, I could do most of that problem in the calculator. Okay? But on the free response part of the test, if you just do all of it in the calculator, you lose points. Because they need to see what your thinking was on the calculator. Okay? So I'm gonna show you some tricks I would have used or how I would write this down. Once we get it, we figure out which is the top and which is the bottom. Okay? So let's get these two things in the calculator exactly the way they look. Okay? Alright, I'm gonna get rid of what's there, so not P. All that. Okay. So x cubed and minus 2x and plus 1. And then we've got negative 2x is my other number. Okay,
You know,
go ahead and sketch that on your paper. Okay. Okay, so notice it's not an enclosed region and we did not graph this piece, right? A vertical line we can get it to graph on these calculators, but it's not going to help us out much. It's basically right here, right? We can just draw it in. So we're looking at the area of that little sliced region right there. Okay? So, what is your top curve? The blue one, okay? Which one is the blue one, the F or the G? Okay. On the AP test, if you are not integrating by hand, you do not need to write this out. You write the name of the function. Because if you write this out and you make a mistake writing it out, you lose the points. But if you write the name of the function, you get the same points. Does that make sense? If I had to integrate it by hand, I would write it out. But if I don't have to integrate by hand, I write the name of the function. Okay? Minus my bottom curve, what's the name of my bottom curve? G of X. Great trick, right? If you have a y equals and a y equals, I would say let the first one equal F and let the second one equal G. Okay? You get full points for that. Okay? And typically 1 point comes from this integrand part, and 1 point comes from the limits. So just setting it up, you get points. Okay? Alright, what are my limits here? What's the top one? Or it's gonna stop where? 1. I need to figure out where it's going to where this crosses, right? So really quickly, you guys still have your calculators up there. Go ahead and calculate your point of intersection. Make sure it's what we predicted. You don't want to just guess, right? You want to make sure it's accurate. What is it? Is it for sure negative 1 down? Oh, sorry, negative 1 2. Okay, so now we're going to do that in our calculator. I'm going to show you a number of different ways. Okay? So, I'm going to show you off the graph and off the calculator page. Okay? I think I know the graph, I don't like this one. Alright, so you got to go to menu, analyze graph, see where it says integral. Grab integral. We're not doing the bounded yet because they don't have a bounded area. social law, you have, there's a way to get it in there if you have to change the typography. Alright, so everybody go back to your calculator page. Okay? I'll show you how to do this on the calculator page. This is the way I typically do it. Alright, and if you work with Mr. Levin's students, his will do it completely different, and by the way, we're way ahead of them now. Okay? But we're going to keep powering ahead because we'll get more review time in the end. Okay? Alright, so we're going to go menu. No, not menu. No. Here's the shortcut. Control minus. No. Shift minus. Shift, is it shift plus?
Yes.
There we go, shift plus. I can never.
Twice.
Caesar Flores found it first. I did it another way for years. Shift plus. Our lower bound was
Caesar four.
-1. Thanks, Caesar. He's the one that found it for me the first time. And then to 1. Now, we're going to use our var. We're not typing functions and we've already typed them in, right?
Correct.
So use your var key. Our top function, I think, was in F1, right? Okay, so F1, you have to put the X in there. And then you do the same thing. We're going to write down exactly what we wrote. Minus, we put parentheses in there for you, var F2 of X. And then we're integrating with respect to X. Oops, not Y. X. And hit enter.
Enter.
Wow.
2. Okay? And you're going to write that down in here. Okay? Equals 2. This piece here, if it was a pre-response question on the AP test, would have been worth probably 3 points. A point for writing this, a point for writing this, and a point for the answer. Okay? But if you only write the answer, how many out of the 3 points do you get? 1. Okay? You have to write this other stuff down. Alright? Okay, let's look at the next one. There's another one in the calculator. Alright, go ahead and delete what you've got in the calculator. Okay, do not be rid of it. Type this in. Oh, this one's a good one. This one looks like superhero eyes. Looks like Spider-Man.
Yes.
Okay, so X to the 4th. Minus 2x. I'll have to find the picture, a cool picture of my son, Spider-Man. I know we don't have any clue about these things in our house. They got him to do the Captain America sleep next to Spider-Man doing his thing.
Is Spider-Man a DC character?
No, he's Marvel. But he's both at Universal and Disney.
What's the difference?
I'm not sure. I know there is one, but I'm not sure. X, 2x squared. X squared. Okay, get those 2 in there. See, it looks like Spider-Man eyes, right? Okay. Alright. I'm going to pull it down just a little so I can see those intersection points. It is a good idea, okay, to calculate these 2 intersection points. Is there a change in the top curve and the bottom curve? No. The red one's always on the top, the blue one's always on the bottom, right? So I'm just going to grab this intersection point and that intersection point. And again, it's a good idea to calculate them. You don't want to just, when you do the integration of the calculator, just click on the point because you might click on the wrong one. Okay? So we're going to go menu, analyze graph, intersection, and get the 2 intersection points. So -2 to 8, -2 to 8, and analyze graph, intersection, and 2, 8. Okay, we're going to do the calculation and then we're going to go on back to the PowerPoint and write up what we need here. I might give you enough dozen places, but right. But it should be given us 6. I don't know why some of our cooperating six. All right. So go ahead and get that sketched really quick. A few minutes of sketch, and then we're going to write up what we need to write up. Okay. Everybody sketch. We're going to write up what we need to write up for AP. Okay. We're going to go through example 3 and then I'll let you go, okay? So I want to make sure you can talk about example 3. Alright, so let's write up what we need to write up, okay? What was my top curve? We add for the G. G was top this time, right? Minus my bottom curve is F. We throw a dx after it. What are my 2 limits? -2 to 2, and then we write our answer 8.53. And you guys, some of you had an extra 3, because the extra 3 there's 3 decimal points accuracy. Okay?
Yeah.
Alright. Let's do example 3. What I will do is I will record example 4 and 5, and I want you to read. I'm not worried about example 6, but I'll record 4 and 5. I want you to read them, watch them over the weekend, okay? So I'll put those 2 up there for you, alright? I record them so it doesn't sound like I'm on the floor. Okay, so we're gonna find the area of the shaded region analytically. Okay, so this one is animated. I stole this slide years ago from somebody else. So here's the problem. You guys have that picture, right?
No.
Oh, you don't? Oh, nice. Draw that picture really quick. Okay.
Wow.
It won't count.
I should maybe just be an artist instead of
Oh, okay. So put this in between the 2 random functions, okay?
What?
Okay, how much time do I for time do I have? Do you want me to grade your papers or fix my
Fix the speaker, definitely.
Okay. Can't wait till next year when there's 4 of them I have to chase after.
Why did you say oh?
Okay, the babies usually squeeze it. Okay,
Speakers and faces.
so I've never done a toddler in baby before. Okay. The toddlers and everything. I told you people are trying to unlock the devil, right? Oh my god. Yeah, he's not even 2 years. Okay, here we go. So here's the issue here. Okay? Don't draw on your picture yet. It's gonna animate here. Okay, so watch what happens. If we try to draw vertical strips across, so we try to add in those little rectangles, right? Do you see how some of the function is over the axis and some of it is over that line? That's a problem. Okay, that means if I do the integration, I'm going to have to do it in 2 parts, which I can do. We've done it like half the period, right? We did 2 parts. Okay, so if we did that, we would have to do this thing, which that's a lot of integrating. Okay. However, okay, so this is what we're going to do. This is the picture. Oh, I went way too fast. Sorry. Okay. We can also find the same area if we went horizontally. So draw that horizontal strip across yours. Okay. So if I did it horizontally, I'd only have to do this function minus that function, right? I'm down to the one thing I'm going to have to integrate versus a double integration. Okay. Again, the double works, but it's more work in the end. Okay. So what I'm going to have to do, let's see, is I have to get it solved for x equals in order to integrate with respect to y. Okay, so you want to write these 2 down that just popped up there. So in order to solve for x, I have to square both sides, so giving me y squared equals x. And if it was me, I would probably write that on that curve there. Okay, so I knew which one it was. Okay, and then in order to solve for x in this one, they added 2 to the other side, so we know that this one is x equals y plus 2. Okay. write any of that. So, what we're going to do here instead of top minus bottom is we're going to do right minus left. Or if you want to think about it as further away from the axis minus closer to the axis. Okay? So that works for top, bottom, right, left. Okay? So it's the right minus left. The more positive minus the more negative. That always works.
Alright.
Okay? Alright.
So the lower.
So the bigger minus the smaller. So whatever you want to get it to goes in your brain. Okay. Alright. So this one right here we said was y equals x, x equals y plus 2, and this one was y squared equals x. Alright, so my more right curve was the x plus, or the y, what happened? I totally messed that up. That's y. The y plus 2 minus my more left curve is the y squared, and we're integrating with respect to y instead of x. So that's why we put a dy. Okay? Alright, so they're going to tell you here, because remember it's technically a rectangle, is what that little strip is there, right? That this piece here is the length of the strip, whereas this piece here is the width of the strip. Which is what we've always been doing. Okay? Alright. So they went through and integrated it for us. Okay? They did that much. So when we integrate y, we say y squared over 2. You don't have to write 1/2, this is somebody else's work, right? We integrate 2, we get 2y. We integrate negative y squared negative y cubed over 3. Are you okay with that part? Okay. They go to a way simplified answer. I'm going to do a little work in between here. What is 2 squared?
4.
So we get 4 over 2.
2.
Plus, let's see, 2 times 2 is
4.
4. And then, let's see, 2 cubed is
8.
8 thirds. Do I care about the 0 part? No. Alright. I could probably reduce that to 2, right? Okay, so here's what they did. They go to, they went to 2 plus 4 minus 8 thirds.
24.
So what's 2 plus 4?
6.
6, but if I want that in thirds, how can we write it?
16. Or 18.
18 over 3 minus 8 over